We are continuing on with our chapter 6 with lesson 6-4, which is all about parallel lines and angles, which seems to be kind of the common theme the last couple of days. But today we're going to kind of be thinking about the flip of it from what we did from 6-3, which hopefully by the end of this you can say, I know that parallel lines form equal corresponding angles and alternate interior angles. So then before it was the opposite of it, that if I knew equal corresponding angles and equal alternate interior angles, I knew that they were parallel. Now I'm able to basically prove the reverse of that, the converse, as we should say. So some of these are going to look familiar, but again, it's just going from one direction to the next. So our first theorem that we have for 6-4 is parallel lines form equal corresponding angles. Again, corresponding angles are those angles that are in the same exact position on this top line as they would be on the bottom line here. So 1 and 3, 2 and 4, 5 and 7, 6 and 8. First corollary, which comes from the theorems that we have, is parallel lines form equal alternate interior angles. Again, we had the flip of it, which was alternate interior angles made the lines parallel. Well, now I know that it's the flip of it is true as well. That if I know that KO is parallel to LN and I have my transversal of JM, I know that this angle here, KFG, and NGF are equal to each other. The two greens are equal to each other, and the two oranges are equal to each other as well, because they're on the inside. All right, they're not on the outsides here. They're on the insides of my parallel lines, and they are on alternate sides. Second one, which again kind of comes as a basic idea from what we've learned before, but parallel lines form supplementary interior angles on the same side of the transversal. Again, that's a mouthful, but again, it's if I know that my two lines are parallel, I know that on the inside here, if I have it on the inside of my parallel lines and they are on the same side, not meaning that they are alternating, I know that those two would add up to 180 degrees, which are supplementary. Again, because if I took this 51 and I flipped it over to the other side, because I know that alternate interior angles are equal, I know that angle MHG would also be equal to 51. And so then I know that my line here, all right, my two angles, my red and then my MHG, would then create that linear pair, which then we know as supplementary from our work from previous chapters. Third one here we have is basically, again, kind of makes sense in the fact that if I, in a plane, so again, just on a flat surface, a line perpendicular to one of two parallel lines is also perpendicular to the other. So if I have two parallel lines here and I have my transversal and it's perpendicular through one of them, that means it's perpendicular through the other. Thinking about it in terms of, okay, so if this one up top here, if I knew that this bottom one, the interior angle was 90 degrees, I'd also know that alternate interior angles are equal. I also then know that these two would be supplementary, which means if I have 90, the only thing that would add up to 180 degrees would be also 90. So please make sure that you're getting those down in your notes, because you will be asked to be quoting them in the homework and on the test itself. Here's a couple practice problems now that we've gotten out of the corollaries and the theorems that we need to kind of use to answer these types of questions. So in the figure below, we know that A is parallel to B. And so if I was going to ask you to write an equation relating the measures of the two indicated angles, basically meaning I have my angle x, or my x degrees here, and I have my 3x minus 40 degrees, which is my this angle here. And so if I know that A and B are parallel, what would you be able to tell me about the relationship between x and 3x minus 40? So again, I'll ask you to pause it real quick and then be able to write an equation down. And once you think you have the answer, then you can just unpause the video. So hopefully you have something written down, and then we're going to create this equation. And so using what I know before, I mean, again, they're not quite on the same side. They're not on the inside of the parallel lines. And so I need to kind of relate these two things together. Well, using what I know before, if I have the inside of a parallel, or my parallel lines here, I know that alternate interior angles are also equal. And so I should be able to conclude that this value is x as well. Now, from that, knowing that if these two are x's and I know that these two angles here form a linear pair, I would know that they're supplementary, which means that if I add x degrees plus 3x minus 40 degrees, that should be equal to 180 degrees. That would be the equation that I would expect you to be writing down, relating the two of the two values. So hopefully you were successful in that. The second part of it would then be, I would like you to find the measures of the acute angle, basically meaning tell me what this angle is, angle x degrees. And so again, pause the video real quick and see if you can try to figure out what the value of x would be for this acute angle. Hopefully you started thinking to yourself, well, let's see here, I have an equation here, so I just want to solve for x. Because I have a plus sign right out in front of the parentheses just pretty much drop, and so I'm just left with x degrees plus 3x minus 40 is equal to 180. And so I would do x plus 3x, which would, again, they're like terms, so they would add to equal 4x minus 40 is equal to 180 degrees. In this next step, you would, again, you have to try to get x by itself. So how do I get rid of 4? How do I get rid of subtracting 40? Obviously, you should subtract 40 first. And so I'm going to add 40 to both sides. That'll cancel it off on the left side. And I'd left with 220 on my right side. And then last but not least, divide both sides by 4. So hopefully in the end, you got your x value to equal 155. Now again, it's getting kind of cut off there a little bit, but hopefully you can see it well enough. Third step though, is then I'm asking you to find the measure of the obtuse angle. So knowing what I have here, so I'm just going to move these up so you can see them a little bit better. If you could for me, again, try to pause this video and tell me if you know what the acute angle is, could you tell me what the obtuse value is? So if you could pause that for me. First step obviously would then be to, if I know what x is, and I have a value of x in my second term, I'd be able to substitute it in, and I'm just going to be able to use PEMDAS to simplify it for you. So 3 times 55 would then be equal to 165 minus 40. Hopefully you then said that your then obtuse angle is then equal to 125. Which again, if I double check my thought process from number 1, it'd say, okay, I want these two angles to equal up to 180 degrees. 55 plus 125 does give me that exact number. Last but not least, the thing that I want you to come to class with, and I want you to try to practice this, is we are going to try to prove that parallel lines form supplementary interior angles on the same side of the transversal. Now again, that's that huge long corollary that we have, but again, basically what it means is, given the fact that A is parallel to B in my diagram up here, I want you to be able to prove to me that angle 1 and angle 2 are indeed supplementary from each other. And so here are my statements off to the left, and I want you to be able to basically give me the reasons for why those things are true. And so if you're going to go through, again, we have A is parallel to B, and so give me the reason why for number 1. Give me the reason why I would then be able to conclude angle 1 is equal to angle 3. From my diagram up here, here's my angle 3. Now again, do not quote that parallel lines form supplementary interior angles on the same side of the transversal if that's what you are trying to prove. So make sure that you are kind of, again, we're following these steps as we go along. And so when you get down to number 6, this is my last statement here, and I just want to note, because I don't know if you're going to be able to see it or not, but it is indeed the final thing that I want to prove, which is basically that angle 1 and angle 2 are supplementary. And so I know you can't see the supplementary part on there, but just, again, last but not least, why am I able to then conclude based off of all these different steps, that direct proof of knocking down the dominoes, why am I then be able to conclude in the end that angle 1 is and angle 2 are supplementary to each other? Please have this ready for our next class period, and I hope you had a fun time learning about parallel lines forming supplementary interior angles on the same side of the transversal, and all those other corollaries that are involved as well. So, see you next class period.